Hi, hello everyone. You are welcome to Induscon 2021. 2021. Um, Here we will deliver some details about the Induscon 2021, the program. All of you are watching Induscon 2001 to the YouTube. During this section, you can make questions and comments to the chat. The chairs, Marcosiris, and co-chairs, Professor Herman, we'll see the questions and comments and deliver them to the presenters. They will answer all questions. We hope that this interaction can happen with success. The first time we will see ever short videos and ever presentations. After that, during the presentations, you can send some questions. And after these short videos, the authors will respond the questions. Professor Herman, good morning.
Good morning. Good morning to all. Hope we can have a good section.
Oh, thanks. Authors, good sections.
Hi everybody, I am Matheus Andrade, and this is the paper called A New Framework and Methodology for Digital Twin Development from Induscon 2021. Hope you like it. Digital twins are one of the technologies arising within the Industry 4.0 context. They are basically the virtual copy of an existing entity of our world, maybe an industrial process, product, system, or system of systems. Although many definitions exist in the literature, digital twins are composed of three elements. The physical object should be virtualized, the virtual object itself, and the data connection between the objects. This paper proposes a modular, scalable, and generic methodology to support further implementations in various industrial cases using data-based models. Modular to facilitate the creation, understanding, and maintenance of the digital twin, scalable to take advantage of the modularity to be applied to industrial processes, no matter their dimension, and generic to serve as basis for every industrial processes. Industrial processes are commonly divided into three categories: discrete, continuous, and batch processes. The last one present both continuous and discrete dynamics. This work is based on the unit manufacturing process concept, for us UMP, to divide the manufacturing process in smaller parts. UMPs are the smallest element or sub-process in a manufacturing system that adds value, transforming the shape, structure, or property of the input material. The process digital twin should be created as the union of the digital twin of each UMP. The proposed framework for constructing the digital twin of each UMP is illustrated in the figure. The digital twin of each UMP should be connected to each other as they are connected in the physical process, in series or parallel. Two digital twins are being created using this methodology. The first one is from a steam distillation extraction of the essential oils process. The figure illustrates how the process works. The second one is from an advanced manufacturing plant, a discrete event process flow with several stages that perform the mounting of aluminum cylinders for didactic purposes. Authors would like to thank for the support of the improvement coordination of higher education personnel in Brazil, the laboratorial support from Senai Cimatec in Salvador, and the company Linux that donated the essential oil distiller that will be used in the case study. And finally, these are the references that were cited in this paper and served as the basis to create this methodology and framework. Thank you all for your time.
Hello there, I am Bruno Castanho Emidio, and I am presenting you the work titled SRM Analysis for Undergraduate Courses, aimed at offering a didactical tool for students to learn more about synchronous reluctance motors, or SRM, and their analysis through the finite elements method. Here, you will be introduced to this class of motors, some of their qualities and features, the theory underlying them, useful equations, and lastly, a case study of an existing article regarding the subject. In this work, we will see the step-by-step construction of a reluctance motor, from its dimensions to the materials composing it. Next, we are going to discretize the motor and use finite elements analysis in order to efficiently and precisely simulate it under a range of values for its electric currents and rotor positions, comparing the results yielded with those in the article aforementioned. Construction, analysis, and simulations of the motor were accomplished in the software FEM, short for Finite Element Methods Magnetics, and run through MATLAB. We expect to show the teaching qualities of the tools in this work, as well as their methods, and to access the advantages of reluctance motors. I hope you enjoy it.
Induscon 2021. This work is presented by Ravi, Fernando Ferreira, and it's about a IIoT solution for predictive monitoring based on vibration data for motors using Microsoft Azure Machine Learning Studio and Microsoft Power BI. This is work for machinery that needs to have better care, so if they're critical and expensive for the industry, it is important to have a good care and know in advance if it's gonna break or not. So the objective is to have a robust system that has data acquisition capabilities, remote data processing, and a comprehensive report to feedback. These are some of the references. So firstly, we determined the better machine learning method to use in our program. Then that was decision tree amongst those that Microsoft offers. Here we use MQTT and microcontroller in order to take this information from the analysis system through the sensor to the cloud, where you can analyze using the various tools, Azure Machine Learning and Power BI specifically. The three kind of problems that we have are misalignment, unbalance, and defective bearing. The misalignment is done in this configuration, where the misalignment occurs at this acrylic junction in the middle. This is the unbalanced, where the unbalance is caused by the bolts, and this is the little motor that wears the bearing, so that it is defective. Here are the results from the data acquisition apparatus. The comparison between the machine learning methods that we tried, and this decision tree, as you can see, is the better one. And here is the final report that has the diagnosis, some pertaining data, And finally, we conclude that it was satisfactory, but it has some things to do better.
Welcome to this presentation that treats intelligent manufacturing systems self-organization in the I4.0 contest. This article was submitted for Induscon 2021. My name is Jackson Veiga at Universidade de São Paulo. A new way of modeling functionalities for manufacturing systems, considering a proposal to deal with emergence by implementing self-organization or plug and produce in the context of Industry 4.0. This work proposal results in a suggested architecture model to cope intelligent systems, enabling coalitions control, relationship, and self-organization of skills, represented in an asset administration shell. Therefore, the copy must follow the RAMI 4.0 guidelines, enabling the connection of a real resource to virtual representation. This model has, at the bottom layer, legacy systems are described as resource and control device. In the next layer, it was proposed NAS concept by an agent motor that performs the integration between legacy systems and administration shell. The previous layers represents the real part of an I4.0 component. The Agent Communication Language, ACL, was suggested to integrate a real and virtual component in communication layer. The information layer is composed of three databases. First, for administration shell, second, for real device, and the last, for yellow pages. The functional layer is responsible for intelligent entities, representations, in aspects of mass control system. The main components are yellow pages, society of agents to coordinate and publish skills, mechatronic resource agent, and the leading coalition agent. The components described are in charge to offer reason and intelligent characteristics for administration shells. The Ardent Kubasa was validated as an ontological description for adding reason and greatly autonomy in elements developed from objects, considered presented by components in the I4.0. The propositions made about engineering capabilities are according to the concept of skill and coalition. It can be a way to solve the gap of capabilities relationship. In this sense, adding a mechanism that enables coalitions of resource skills represented in an administration shell. Architectural considerations are at an early stage, enabling reflections on the paradigms proposed in the I4.0 guidelines. The purpose of this work is suitable for systems that require greater autonomy and decision-making. Well, these last features were enabled with MAS and EAS concepts.
welcome to this presentation. My name is Benedict Shombe. Right? I'll be the host for this presentation. Right, with me on this on this publication is Jennifer Freitas dos Santos, among Christian Fernandes Araújo, Wellington da Silva Fonseca. We are basically representatives of the Federal University of Pará. Right, now, the topic of this presentation is the implementation of digital twin-based monitoring system of induction motors. Right, now, let's get in and understand what it is. The concept of a digital twin integrates the actual physical system, which is a motor or any electrical system that you'd like to measure, right, with its virtual replica, which is a simulation that might be occurring remotely in another place, with the help of models, sensors, data, software to monitor and analyze future performances. Now, the use of digital twin for monitoring is promising because it allows for the application of predictive maintenance for hours, right? Now, the difference from this work with other works is that we are able to implement our system, in this case the digital twin, with the implementation of the finite element method, which is quite a well-consolidated method, numerical method in this case. Now, in order for us to understand better our system, basically, it composes of a motor, and this motor, the current is measured through a sensor, which allows for digitalization of the data through a microcontroller, and it is sent to a database through an access point. In this case, we use Heroku Postgres database, right? And this information is accessed in the format of JSON through Python, and it is inserted as inputs within the finite element method. In this case, we are using Faint in order to do this, right? Now, some of the results that are quite interesting that we have obtained here is basically us being able to monitor the phase current over time, right? As well as be able to analyze the magnetic flux of the motor from its operation, right? Now, within this, we are able to conclude that this article has really proposed a digital-based monitoring and analysis system for induction motors with a differential of performing thermal magnetic analysis using finite element method.
Hi everyone, my name is Fernando Ferreira. I'm from Escola Politécnica USP, and I'll present our projects today. Our project is based of determination of camera position in soccer game, and this is the summary of my presentation. To begin, to do an introduction, the automatization of the analysis of soccer videos, it's becoming very popular nowadays. This happens because the popularity of soccer combines with the necessity of extracting a lot of information from a vast amount of matches in a short period of time. And one of these steps that is very important is the determination of the camera center. And to do so, we are going to use known points in the soccer field image in order to determine the homographic matrix and consequently the camera center projection. In our projects, we did some improvements to minimize the distortions, and furthermore, we use not some common methods for the calculation of the homography. Here are some results of our projects. In this step of homography calculation, we use as input this image that is the final game of the World Cup 2002 World Cup, and we use these lines with this virtual point that is not appearing in the image, and these lines in blue, these points in black and the lines in blue. With that, we reached these results, with these 4 results, when you use only points with normalization, line using points and lines without normalization, here using points and lines with normalization. And compare them there, we have these results, so we can conclude that the best one is the points and lines with normalization. So we improve a lot our hours of graph calculation doing that. And the results in camera center calculation. To do this calculation, we need 6 points, 2 in the crossbar, 4 in red. So we have now 3 combinations and 3 results. The results are the pink dots. Then we combine with the algorithm methods to choose the best homography. And here's the results. To have a reference, this is the 3 situation with the coordinates of the results of the coordinates. And here's the system that we use. So here, in this coordinate is the region. So the results was okay and was. And to conclude, we saw that the homography normalization and using lines show best results. So we improve our homography calculation methods, and the same was not supported by the camera matrix. And as a future work, we are going to combine these to create our own dataset to feed our artificial neural network algorithms.
Hi, thanks for everyone. We have some questions. Professor Milena, about what work is your question? We have a question about how many data Ravi's work. Please, Ravi, how many data was used for training and validation? Ravi?
Oh, oui?
We have one question. How many data was used for training and the validation?
I'm looking it right now. I don't really remember. Can I have a little time?
Yes. And for the second question, Professor Milena, for this DT-based article, which sensor will be used? What work is? The first one. Ravi, the first one is regarding the rotatory machine.
What?
The questions is about regarding the rotatory machine.
You mean how many data points?
Yes, how many data was used for training and the validation?
Yes, I am looking through it. I don't remember right now the exact number.
But oh, that's great. After that, we can ask you to send some email for you, and you answer these questions. It's okay for you, Ravi?
Yes.
Yes, great. Thanks, Ravi. There are one second questions. Second one is for Benedict. Benedict. Benedict, for this database article, which sensor will be used? Benedict, yes.
Please repeat the question again.
Is a question from Professor Milena Ferreira. For this database article, which sensor will be used?
We use the current sensor that is SCT 100. You can look it up. It's one for magnetic induction that we're using in this case. Can I show on my presentation maybe, but then I have to enter on this side. Is it okay with you guys if I enter?
Yes, it's okay.
Okay, just hold on. Let me just get in the link here, then I'll be able to show it here on the screen.
Okay, thanks, Bennett.
Just hold on. Okay.
Bennett, everything, it's okay?
Yes. Can I present here?
Yes. Probably you are in the mute mode, Bennett. Bennett, you are in the mute mode when you are presenting. Bennett, that's great. Bennett, everything okay now? Is mute yet? Yes.
I don't know. Can you hear me now?
Yes.
Can you hear me? Is it okay?
Yes. Now, yes.
Okay. Thank you. Okay. Can I answer the question? In this case, we used this kind of sensor, right? Which is a SCT-013 sensor in order to acquire the phase current. Okay? I don't know if I have been able to respond to the question, but that's basically what she asked me.
Yes. Bennett, there are
Yes.
another question for you from
Okay.
Professor Milena. And from Marcos de Sales Suzuki. Can you see the question?
Yes, let me just read it. Another question to Bendik: is it already an experimental analysis or just theoretical? Until now, it's validation, whereby we have a motor operating. In this case, I can show on my presentation. Excuse me, let me show it again, right? It is a validation whereby we are taking the information from induction motor, right? The 1.1 kilowatt motor 3-phase, and we are able to feed it with that motor in such a way that we are able to simulate it. So it is both an experimental measure as well as a simulation-based system as well. I hope I've answered your question.
The next, there are another question.
Yes.
Are you using encoder to obtain the speed?
No, in this case, we are not using any encoder. We basically
Hi,
only
everybody.
use.
I
Renata, sorry, about the encoder?
No, we are not using any encoder until now to obtain the speed. That's why in our experiment, if you look at it, we did not measure speed. We didn't measure the speed of the motor in this case. However, it's one of our proposed future works that we're planning to do.
Okay, thanks.
Okay.
Professor Herman, any question?
Yes, just take the chance to Benedict. I didn't understand. Well, it was not clear because it was too short, the presentation. But how do you filter the data to transmit it by Wi-Fi system to the cloud? Because I suppose you must filter it considering the huge amount of data you have to do on the edge before transmitting it to the cloud. How do you manage that?
Time frame that we have taken, right? And in this case, we measured a data frame of 40 points, which was so for 400 points that we did during the day. We choose a time and we just do the experiment. We do not let the motor work all over the day. We have not performed a daily analysis of it yet. We only start the motor, do our experiments, and switch it off. That's what we basically do. And we take those data points and we analyze them.
Okay, for Benedict is this, Marcus.
Are you planning to use a type or current inverter to control the motor? Until now, what we have done is we have basically only done direct actioning, partida direta, no caso. We haven't yet used an inverter to control the speed of the motor in any case. However, over time, we are still modeling. For now, what we have done is we wanted to obtain the flow of current from one side onto the simulation, and from there be able to validate it with what we have on the readings of our chart in Python in this case. So in this case, we have not performed any variation of velocity with current inverters.
Okay.
Perdão. Is there still another question that I may answer, or is it okay? The transmission on?
Yeah, I think we have a problem here. Professor Marcosiris is coming in again.
Okay.
Let's wait a bit.
Okay.
Okay, Professor Marcosiris is asking me to take charge. He's coming in, but meanwhile, is there any other question to Benedict? Okay, thank you, Benedict.
Okay, thank you very much.
Just going further, I have a question, a particular question to Jackson Vega. Jackson, could you explain a little bit better how do you manage your system to be intelligent, considering you have a self-organizing system for manufacturing, intelligent manufacturing? What is the intelligence, and where is this intelligence in your system?
Hi, Professor Herman. Thank you for your question. Maybe you are asking me now about the intelligence and the society of multi-agents.
Yeah.
Okay. There is a intelligent system because we are treating different paradigms for control the manufacturing things in virtual assets. So the intelligence is about the reason for the multi-agent society combining itself to organize the process for manufacture some products. In this case, the paradigms is not using service-oriented architecture. When we are represent some ability or skills in the product, that means searching for new capabilities in the administration shell. We should use some traditional architectural aspects for organize the things, you know. So if we wanna planning use the resource, we just specify directly the abilities of the resources in the planning. That's how it happens. But in my proposal, we are treating a way to make this organization seeking for a new way of use intelligent entities. That's some active representations. If you are seeing in a digital twin, the things are represented as services, okay? But the multi-agent societies are like is not like a passive thing. It's an active thing because they have a reason. In the article, I didn't have implemented the intelligence yet. In aspects of decision, we just have treated the process to model the agents. And I have validated the process to decide how these agents communicate one with each other and with the representation. In future works, I will use some methods for simulated and apply the multi-agents characteristics for reason and decision. that is means intelligent aspects.
I understand. So just to make it a little bit clear, uh, your approach focuses mainly on the mass part of the manufacturing process. Is that right?
Yeah, yes, exactly. I'm treating just the functional layer in the HAMI 4.0. That
Okay.
means the decision layer.
Okay. Professor Marcosiris, welcome back.
Thank you.
I just was making some questions to Jackson Vega, our uh, focusing on his research work. And so, sending back to you. You are mute. Uh-oh. Still mute.
Hello. Hello.
Okay.
Yes,
Now
so,
it's
so
okay.
we don't have any questions about YouTube. Yes, then we can make some questions. Um, some authors, there are any authors who use the same. Just a moment, yes. Some authors use another work with FEMM. They both can take a little conversation about these works. Bruno Castanho.
Yes, good morning.
Yes, good morning. You can talk with another work who use the FEMM.
Yes, it was Benedict's work. Is he available?
Yes, and you can make some comparisons about these two works.
Sure. I would like to hold some talks with him. Benedict, are you there? Can you?
I'm available. Yeah.
I was kind of fascinated. I wasn't expecting another work using the same tool. It was pretty useful to me. Mainly the the draw. Well, I used it actually through MATLAB. What about yours?
Well, mine, I used it through Python in this case. I use PyCharm to be able to do it. And in this case, I basically used, there is what they call Python, which is the
And
library that they use in this case. So what happened basically is that we take the currents from the database, in this case, the Postgres Hiroki, and we download it, and these currents are the ones that we simulate. And then from there, we are able to look at the magnetic flux and as well as couple it with the thermal part in this case. That's basically what we're trying to do today in order to see. However, in this case, we didn't show much of it, but at the point we are also using thermal photographs in order to look at the temperature of the motor and verify it with the simulation in this case. I have a curious question. I didn't get to see much of your presentation in this case. You were talking more physical. How do you perform your simulation in this case? How is it? How is it done? Because I hear you using a reluctance motor, if I'm not mistaken.
yes. It was not using MATLAB. We had uh, it's available Octave, a manual with all the command lines one can use. You use you use thermal properties. I tried, but wasn't necessary to my work. Also, you your model has rather complex geometry. How do you draw it?
In this case, to draw the geometry, we had to look up at papers, right? Some of the papers in this case do avail the geometry sizes, and then when you draw them, you have to you basically draw one of them, right? In this case, when we're talking about the slots, mostly are the ones that are difficult to do. In this case, it's induction motor, so it's much more simpler. You take that, and then you basically copy it, depending on how much poles your motor is. Then you copy it. That's basically how you do it. You just need to know the slots most of the times. You can get it as well from other uh, softwares that are much more complex in this case that have some examples available like ANSYS and SolidWorks. Most of the case in AutoCAD also has a few examples that they have, so you're able to copy some of the geometry from there.
And you use the auto mesh, or did you personalize it?
I had a bit of difficulty in this case because when simulating only one time or one rotation, it's okay. Basically, you can use auto mesh, it's fine. However, when you are simulating with, how do I say, when you're rotating the motor for 360 to get the torque almost, it becomes difficult in this case because it takes a lot more time. So basically, you now have to reduce your mesh size and all of this stuff in order for you to get your simulation going. I wrote it in my article at a point as well.
I understand. I have questions for now. I read your work later because, well,
Okay.
I would like to. Do you have any?
I'm fine. I'm good. It was more theoretical in this case. Your paper in this case, right?
Yes, we are reference to learn. Can you see me?
Yes,
Anyway, we tried to develop, or rather, to show a tool to students to understand the reluctance motor. We found out that MATLAB alongside fan was a very useful and rather what is the word actually? Very intuitive.
Helpful.
Yes,
Actually, there are some other works that use the same method in order to teach. I remember at our university as well, there are some works going on of people trying to teach students and through the finite element method using FEM in this case.
I believe Mr. Vega has a question.
I'm not sure. Okay.
Is it to me or directed to Benedict?
I haven't seen the question yet.
Yes, he called in the chat. Jackson? You are mute.
Yeah. And it's possible to hear me now?
Yes, we can.
Okay. I'm not sure if I can make the question about another paper, or is questions just about the paper from Benedict?
Is the question to Huns?
It's all the group? Yeah.
Oh.
Yes, you can ask for everybody.
Okay, thank you. My question is about
Bruno and Benedict. Thanks a lot.
Okay.
Thank you.
I think it was the second paper that treats machine learning in that data acquisition. Who is?
Which paper, Jackson?
It's the second paper that treats machine learning data acquisition. Let me. I think it was about implementation of database monitor systems. Of induction motors. That's it.
Is it this section?
Okay, but I have another one about digital twins that's more clear. Digital twins was treated in the first one, a new framework and methodology for digital twin development.
No.
I think it's Matheus. Matheus is in the Matheus Andrade. Okay, Matheus. My question is about the
everybody.
state. Okay. It's about the definite state machine. You have represented, try to simulate the magnetic flux. Something about that. I would like to know if you could explain in more detail how do you have used the finite state machine inside the digital twin? Or I'm confused about your work. Sorry.
So I'm proposing just a methodology and framework for digital twin development for every industrial process. So we are avoiding particularities that only work for one or two industrial processes. So we are trying to make it work for every industrial process. I don't know if I answered your question.
Yeah. The question about your work is each part of the digital twin in the industrial process have you represented or was not clear in the summarized presentation?
Which
did you understood?
which part?
You are treating process industry and in digital twin, but what you are thinking?
Every kind of industrial process that could be censored and instrumented properly, so we can have data and use actually artificial intelligence to process this data, and then we can generate some answers to the actuators, so they can implement the results from the simulations, basically. I don't know if I understand your question.
Yeah, I will try to use you answer with some aspects of sensors and actuators in the process plant, but you also talked about the artificial intelligence. But in digital twin, we have some particular aspects of representation. And in my case, I treat the industry, the industry that makes some real product. And in your case, you are treating maybe some flux of material.
Yeah, it's because digital twins can be of you can create a digital twin for products, for industrial processes, and so you have different approaches to create them. So we tried to our concern was about the industrial processes, no matter their dynamics, batch processes, continuous processes, or discrete processes.
Okay.
We are proposing a multi-agent approach to.
What? To what?
To our work to deal with the particularities every industrial processes can bring.
But you said that you are proposing a framework. Each part of the process are you focusing?
The framework is for every step of the process. We are dividing the complete manufacturing processes into UMPs. There are unit of the process that perform some changing in the raw material that comes inside the UMP. And so we could, dividing the process, we could deal with the complete industrial process.
Okay, thank you.
The modularity we are trying to bring is just to divide and conquer, the philosophy of divide and conquer, basically.
May I ask one question to Jackson?
Yes, Bruno.
Actually, it's to you too, Professor Marcosiris. I see you and Jackson co-wrote the article. Could you please provide us some details, some comments?
Some details about?
Your article. I would like you to talk of one of our hosts, also authored it. I am curious about it.
About what specific part, Bruno, or everything? Do you have any
Everything.
specific part?
No specific part, no details, just comments. Talk about it, if you will.
Yes.
Given we have no questions for now.
Well, the Jackson's propose a multi-agent. He went to propose a multi-agent framework, and in this case, he are using the RUM 4.0. Yes, the RUM 4.0 is a methodology used for the industry 4.0. Yes, and here we will try to use the AAS part and AAS components. They get a lot of works about the multi-agents and try to join this work. And this work house Jackson are using, they don't was used in the context of Industry 4.0. Yes, now Jackson trying to put these works in the context of the user in Industry 4.0. They see a lot of research about this and see many parts that can be used in this case. Because Industry 4.0, there are certain details to use. And now we need to make a lot of tests. Yes, to check with all these parts together how it's working very better. Yes, Jackson, you can improve and more.
Yeah, sure.
Yes, you can choose any part of your work if it's necessary.
I feel comfortable to talk more specifically when you had talking a lot of Industry 4.0. In this case, Industry 4.0 and you said something about the administration shell also. The big challenge in my proposal was specify a process for changing the traditional systems, the traditional manufacturing systems for the context of Industry 4.0. When we are treating Industry 4.0, that is the concepts of manufacturing in a digitalized way. That means basically the sharing of resources in my case, but the big goal of the Industry 4.0 is establish the virtual world in the context of industry where everything is connected, everything into big vision, horizontal and vertical. When we are trying vertical is outside of the company, connecting another companies and all the chain of the manufacturer, like logistics, the shop floor, and the sales, and the business, and other things. And in my case, I'm looking more for the machines and the manufacturing process. When we have some build of materials, and you need to construct something that could work for a big universe, but I have focusing in a smaller part, imagining 2 or 3 machines that need to develop something or join something. And we in the first case, we had proposed how to virtualize these things. For those, we have used AAS. AAS means Asset Administration Shell. That's a way to make a ontological representation for the assets or things when we are looking for IoT. After make that and know the things that are proposed by Industry 4.0, that is a German proposal for patronizing the things in the context of I 4.0. We have seen the engineering part for representing the manufacturer, or how the engineering and the process of manufacturing happens in the real context. So yes. I have used a multi-agent system that is an intelligent paradigm for flexible and distributed control.
Yes, in this. Thanks, Jackson. Sorry, but you are.
Thank you, Jackson.
Sorry, Bruno, but we are on time. We need to close the sections because will be another section. Everyone who wants some questions about other papers, you can send one email to the articles, every articles that are the author's emails. If there are any questions and specific questions, everybody can send these emails. It's
Professor,
okay? Yes, Bruno?
It seems Marcos Suzuki says it ends at 11 and a half, our section here.
Oh, yes, then that's great. Well, there are another. Yes,
it seems we have another 30 minutes or so.
Yes, that's great. There are another question, or you prefer Jackson continue to answer your question?
I found it very fascinating, but I would like to ask a question to Matheus, if I may so. Matheus? I've seen you and Professor Herman also co-wrote an article. Could the both of you talk about it?
Yep.
Same as Professor Marcosiris and Jackson just did.
So Herman is my advisor, my dissertation to get my degree, my master degree. So we created this. We are creating this framework to create industrial processes, digital twins. Herman, do you like to say something?
Okay. Well, Jackson, this approach that Matheus uses, by the way, is very interesting to say that I suggest that Matheus can talk to Jackson later on because those are very complementary approach to the same problem and maybe useful for them to talk to each other and understand a little bit better how each one is working in this process. Because Matheus would approach more focus on the generalization of the digital twin process for the manufacturing itself. As Matheus said before, for digital twins, you have a lot of different approaches. Use it, for example, to fine-tuning the performance of one equipment, of one part of one equipment. For example, one research work here presented how to better tune one specific motor for a better performance, considering its IFAM results and so on. But Matheus was getting one approach based also in agents that can be generalized because he embodies the intelligence in each agent. So we are talking about cognitive agents that can talk to each other by, how he said before, negotiating the better solution for the whole process. Okay, so this is a very interesting approach because you can put the intelligence can evolve by the time, by the process, if they are learning with the process by itself, and you can also scale it because the agents are by themselves independent. So when you have the models for the class of agents, you can generalize it. That is what he's seeking in his research work. That's why he's working with one process that it's also not only continuous, but it is also the batch process. So you have a mix of situations of batch process, continuous process, discrete process that can be fine-tuned by his approach. Okay, that's more or less the broad idea. Is that it, Matheus?
Excuse me, both of you. It seems Jackson has a question for Ravi, but first I would like to ask a final question. It's Linux donated you a oil distillery. It means your dissertation had a practical part, a practical section, or was it just this article?
Matheus?
Yes, we are currently working on a case study using the essential extraction process by steam distillation as this case study for our work. We have a colleague of us join the resources, so I'm actually helping him. His name is Carlos, and he is working with the automation of the essential oil extraction process. and I am using this all this how could I say, everything, all the equipments he's gathering together to make his work. So I am using all these equipments to do mine. And we have two PLCs. We have a Raspberry to help monitor the production process. We have a SCADA system, SCADA software to also monitor the process, and I'm creating the digital twin to help him with his work too. My work is kind of a case study based on his thesis, so kind of. Got it?
I understand. Thank you, Matheus. I have questions for Professor Herman, but it's for another work of his in this Induscon. So thank you both for your answers.
Thanks, Bruno.
You're welcome.
Pass my words to Jackson. Thank you.
Thanks, Matheus. Thanks, Herman. Jackson, I have one question for Ravi.
Yeah, sorry. First of all, could you hear me or not?
Yes.
Okay. First of all, I would like to thank Mr. Herman for the explanation of the great work that he is making with Matheus. For me, it's clear now the agência or the multi-agent system, the proposal of the multi-agent system, the better and the process aspects. You had suggested some things for creating models for digital twins in better process. In the case of the work that I'm doing in with Marcosiris, we had detailed the agents, the models for the agents, and we right now we are in a step to simulate these virtual parts, not about the reason of the agents, but about the way like the things happens, So we have all the extruder of the agents that will be encapsulated in the virtual parts, that means digital twins. That is I'm treating agents like you said, cognitive parts also. And I think that could help Matheus if they want more information. Feel free to contact us. Thank you. Ravi, Helon, my question is about you had treated IoT solution for predictive monitor based on vibration data for motor using Microsoft Azure Machine Learning Studio. That's it?
Yes.
Okay, thank you. When you presented this, I had understood that you are getting some data from the motors, real data from the motors,
yes.
And you are not treating simulation, but maybe you are using Azure for make some predictive things, but it was not clear if you are trying the vibration of the motors or if you are analyzing the magnetic field of the motors. Could you explain a little bit better the aspects of Azure using the decision or the training of machine learning for data acquisition of the motors?
Yes, vibration data is not magnetic, it's the vibration of the motor. And the motor vibrates when he has some fault or such. There is a different vibration that acts in different frequencies. Like, let's say one of the problems we analyzed was unbalance. In these cases, the first order, second order, like the frequency the motor is rotating and twice as that, it's different, these frequencies. So we are using machine learning through Azure to identify when these vibrations occur differently than it would occur in a healthy motor. Did I answer?
Yeah, a little bit. It's not clear for me. How do you access the data from the motors?
We
I'm not.
use accelerometer to
Yes.
gather the data from the motor.
And you
It is mounted
connected
in
these data directly from the Azure.
the data goes through our data acquisition device that we use with Bluetooth and Wi-Fi capabilities. The Wi-Fi sends it to Azure storage accounts from Microsoft.
So this
Storage
sensors
account
is an intelligent one. That has a standards port for like OPC way or something that
OPC
connected
way.
directly OPC way.
Yes.
And it's in the loop, actualizing the data. And in the Azure, are you treating some artificial intelligence or
no, it's not
regress or no?
We are doing it manually. I don't know now because I'm not in the project anymore. But when we did it, we would pass each part once in a. We do it, but it's not on the loop.
And you have used some keys of the Azure for training. That's it, or you have specified the key for make the training and the understanding of the vibration.
We are trading the keys between the different parts of them.
Yeah. Okay. It's not really clear for me, but I need to be more. I need to read your article and understand better how do you make it.
Okay. Feel free to ask.
Thank you.
Thanks, Jackson. Thanks, Ravi. Professor Herman, there are any questions?
No, I think for me it's all clear. Thank you.
Yes, I have a questions for Fernando about the work determination of camera position in soccer games.
Yes, hello everyone.
Hi, Fernando. Hello. Fernando, with normalization in the determination of the homographic matrix, is preferred as they show smaller errors. How it's work?
Like the calculation of the error?
Yes, you can choose about the normalization.
To calculate the error, we had the model image because the field we have the dimensions, like they follow a pattern of FIFA, so we know where the points should be, and we did all the calculation of the homograph, and we transformed the original image into the model. So we sum all the distance of the place that they should be and the place that they are, and we do the sum, and the number that's showing like 83 is the sum of these errors. So the last one was better because the sum was the below. So there's not, so they don't have a lot of errors. So the image is better to see. So it's better to correct the distortion.
That's great. It's possible for you to show for us?
Okay. Can you see my presentation? Here are the calculations, so you can see that don't change a lot, but if you do the sum, the first one was 87, and the last one, that is when you use pointing lines, doing the normalization, it was 84. So you can see that the position of the points change a little bit. Sorry? Okay. Anyone are listening to me? Maybe you're muted.
Marcos, you are muted.
Sorry. Do you have any simulation about it? Because
yes,
it's very interesting to see this.
About the homograph
Yes,
calculation?
yeah,
About
yeah. Yes, about
yeah, we have this for, okay. When we did the camera center calculation, we used the best solution that we had with the homograph because we show a bare image of the, like we are seeing the field by above. So it's good to see them with a good correction of the distortion. So these 4 examples are using the best homograph. That was the last one. I have this 4.
That's great. And the codes are not too easy, yes?
Yes, the homograph is not so easy because a little bit of difference, because when you are doing by pixel, you cannot pick like 1.5. You have to pick 1 or 2, and because of that, the error increased a lot. So it was not easy.
That's great. Yes. Thanks, Fernando.
Thanks.
Yes, thanks, Fernando. Sirs, anybody that are any questions? No. Well, thanks, Fernando. Well, I believe if there are any questions, we will finish the section. Herman, it's okay?
It's okay. Thank you very much for the presentations, for the participation, and for the answers, questions. So I think was very interesting. Thank you very much.
Thank you for all the others, because this section and this Congress was possible. And you are everything, everybody are invited to next Congress. And post-Congress, we will have a lot of, we have 3 journals. There are 3 journals that are possible to you send the works. Okay, everybody received the email about it. Thank you for everybody. Thanks, Herman.
Thank you too. Nice to see you. Okay.
Nice to see you. Bye-bye.
Bye-bye.